So let's talk now about where do we actually get the alkanes from and what are they used for. So let's talk about sources and uses of alkane. Alkanes come from two main sources, and these two sources are vast, and those are natural gas and petroleum. Now natural gas is obviously gas, so it gives rise to alkanes with low boiling points, basically alkanes between C1 and C4, while petroleum gives rise to C5 and higher alkanes, which are separated through fractional distillation of petroleum in refineries. And various fractions of both natural gas and petroleum are used for different things. And this is crucially determined by the properties of alkanes that are components of those fractions. So let's look at now individual fractions and see what they're good for. The C1 to C2 fraction is obviously methane and ethane, and they're gases. That is pretty straightforward, but they're also very difficult to liquefy. So they're used either as fuels, as gas fuels, and they're very prevalent fuels in that respect, or they're used as liquefied fuels, so-called liquefied natural gas, where methane is liquefied under very high pressures, and it's one of the cleanest burning fuels nowadays. Moving on to the higher alkanes, C3 and C4, these are gases as well, but they're easily liquefied because their boiling points are much higher than methane and ethane. And so propane and butane are also used as common fuels. For example, your camping stove is probably going to run on propane. And so they use as fuels, but they also use as freon replacements. Freon is a fluorocarbon, so it's a halogenated compound, organic compound, which was used in aerosols and refrigerators. But since it was found out that it destroys, that various types of freons destroy the ozone layer, they've been very quickly completely removed from use and replaced with propane in aerosol cans. So this would be deodorants or something like that. The next fraction is C5 to C8, and these are liquid alkanes, but they're very volatile. This is a very important fraction because this constitutes gasoline. And the volatility of these 4 or 5 alkanes is crucial in gasoline's combustion because the combustion in your internal engine in the car happens in the vapor phase. So the air and the gasoline vapors are mixed, and then a spark plug ignites them and creates the propulsion in the engine. And that's why it's important to have a volatile alkane because non-volatile alkanes will not get into the gas phase very quickly. Now, not all fuels, not all gasolines burn equally. Some burn very, very nicely, very cleanly, while others tend to engage into engine knocking, which means basically that they have ramps of explosive decomposition, which leads to this specific sound. And of course that is something that's undesirable. So various gasolines have variable ability to knock. And the measure of that knocking ability is the octane number. Octane number is named after an octane. So this is an isooctane, which is a very nicely combusted compound because this resists knocking. And as such, this compound was given an octane number of 100. On the other side of the spectrum is heptane, which tends to knock, so it is not a very desirable fuel, and it has an octane number of 0. And as we move from octane from heptane to isooctane, the octane number increases. Now, gasoline has other components as well. But in petroleum laboratories, when they study the properties of gasoline, they compare actual samples of gasoline to mixtures which have variable percentages of heptane and octane. And when they find a mixture which behaves exactly the same as the gasoline they're studying, then they assign that corresponding octane number to that gasoline. If you go to the gas pump, the gasoline that you're using in your engine is typically higher than 90 octane, so it's 96. So. Now, moving to even higher fraction of petroleum, the C9 to C16 fraction is less volatile, so they're still liquids. And these are components of kerosene, jet fuel, and diesel fuel. Kerosene was used in lamps, but now it's used in some agricultural vehicles. Now it's sort of not used quite as much. And jet fuel is very similar in composition, it's used in jets obviously. It's similar in composition, but it's not quite, it's a little bit cleaner. There's some non-alkane impurities are removed from it. Diesel fuel finally is used in tractor engines and actually in a lot of European cars. It has a higher melting point, and so sometimes it freezes. And actually, in Europe, for example, there is one kind of diesel fuel which is used in most of Europe, but there's another kind of diesel fuel called the D1 fuel, which is used in Russia because their winters are really, really cold, and so this fuel has some lower alkanes added so that it doesn't freeze in the engines. Now, even higher fraction, C16 to C30, is no longer a liquid. So this is now, it's still a liquid, but it's becoming a very viscous liquid. So these are the so-called mineral oils, as opposed to plant or animal oils. And they're used as heating oils, so as heat transfer fluids, or as lubricants. When you go to change the oil in your car, they will probably replace one mineral oil, which was dirty, with another mineral oil, which is clean. Even higher fractions, and these fractions overlap a little bit, C25 to C30, is called the paraffin wax. Although technically speaking, waxes come from animals and plants. And this is a solid now, and it's a mixture of higher alkanes. This was used for candles, for example. And even though paraffin is a solid, it's still lighter than water, so it will float on water. And as we get even higher, distillation becomes more and more tricky because distillation requires a volatility, and these higher compounds are not so volatile. So this thing that is kind of goo that is left on the bottom of the refinery is the highest thing, and it's used as asphalt. So roads are covered with petroleum derivatives. Now, as I mentioned already, basically the procedure for getting this is that you have an oil well, which then takes crude oil to a refinery, which then produces these different fractions and market them. Okay. As one of the side products of production of oil is methane. Methane is first found by itself in natural gas wells. But then it's also a side product in oil production. But perhaps most interestingly, it's also found, it's produced by bacteria. For example, bacteria and other microorganisms that populate cows' stomach produce methane. And this is actually a huge source of methane. It's about 300 million metric tons each year. But since it's so diverse, I mean, every other animal produces it, it is not used presently. Because we have no technology to get to this methane, collect it, and use it productively. And that is a bit of a problem because methane is a gas, so if it's not used, it's released into the atmosphere. And in the atmosphere, methane actually contributes to the global warming much more than CO2 does. And because its percentage of carbon is higher than in CO2. And that's posing a bit of a climate problem here as well. And actually many refineries which produce methane and cannot immediately use it, burn it. And so on top of many refineries you see a flame, and that's just burning methane. And it's going to sound a little counterintuitive, but they do that to reduce the pollution, because as we'll see a little bit later, burning methane converts into CO2, and environmental impact of CO2, although still substantial, is lower than that of methane. So instead of releasing methane itself into the atmosphere, these refineries convert it into something less harmful. In the next and the final topic, we'll talk just a little bit about the reactions of alkane, and we'll come back to this combustion issue.